right, now we're ready to look at the basics of doing statistical hypothesis tests. So we want to compare one group to another, a group to a target, many groups to each other, and we might look at comparing means, standard deviations, shapes of distributions. So we're going to cover a variety of tests, but let's take a look at the basics of how we set up and perform a hypothesis test. So in this section, we're going to cover the basics of setting up and performing hypothesis tests, talking about practical versus statistical significance. What kind of risks are we willing to take? So we're going to go back to that truth table that we saw in the decision systems analysis, or the attribute assessment agreements, and all the different types of hypothesis tests that we can do. All right, so we're a little over the halfway point in the analyze phase, and so we've done some filtering, graphs, we've done FMEAs, we've done fishbone diagrams, we've done XY matrices, and we're starting to get a feel for which X's are in and which X's are out. So we can now take them one step further through doing these statistical hypothesis tests and see whether or not X truly does have an influence on Y, or the question up here, is X a vital X? So X's can have an impact, and we're going to decide based on the type of test we pick on, are we looking to influence the mean or the median, the central tendency, the standard deviation, or the spread. We can even do tests for the shape of the distribution. So a hypothesis test that we've looked at already, is our data normal, yes or no? So we're going to use this statistical analysis to further our knowledge of XY. All right, let's look at the basics of a hypothesis test. It's an upfront theory, so we say, hey, what's your hypothesis of the relationship between X and Y? There's two contradictory outcomes, so we're going to say the null hypothesis, or H sub 0, assumes there is no relationship between X and Y, that everything is just noise. There is no relationship, and that's the base standard. So what we try to prove, if we really think X and Y have a relationship, is the alternative hypothesis, sometimes denoted H sub A, sometimes it's H sub 0, H sub 1, but we just want to distinguish between the two. The alternative states that there is a difference or relationship between X and Y. So as I move X, Y changes, and I can prove that there's a statistical difference in mean or median or standard deviation or variance or proportions, depending on the type of test. So we say here, it is the hypothesis that we are trying to assess, or we are trying to prove. Because if we don't prove it, then we say there is no relationship, and we're going to remove that X from our funnel and move on to the next one. All right, here we have a nice example based on a transactional process, and we're trying to improve the cycle time for the process, and we have a hypothesis that method has an impact on that cycle time. Now, method could be person, it could be location, or perhaps we truly do have two different processes that we put our transactions through, and some people like process A and some people like process B, but we have a feeling that there's some impact on cycle time based on the method that we used. So in the null case, we're going to say, method doesn't matter. So method used to process transaction has no impact on cycle time. This is the opposite of what we're hoping by doing the test, but it is assumed to be true. So unless we can reject the null in statistical speak, then we're going to remove that X and take it out of our funnel. On the other side, what we hope is true is that method does impact cycle time. And again, the statistical doublespeak is that we reject that the null could be true, that they're the same, which means then they must be different. So we really are making sure that method is an important X. And so if we reject the null hypothesis, then we're going to say that method is indeed important.